Welcome to section 1.2 functions. We're going to be looking at function notation and evaluating functions. We're going to find the domain and range of functions as well. First thing, what is a relation? A relation is just a pairing of elements of one set with the elements of a second set. We have a lot of different relations, but our main focus today is going to be on functions. We can give examples of these by tables, mappings, ordered pairs, graphs, and equations. We want to talk about independent variables and dependent variables. Independent variable, as we talked about the other day, that represents your x value, that's your domain or your input. And the dependent variable is your range or the output, which typically we call y when we're dealing with graphing and stuff like that. It doesn't have to be, but that's in terms of input, output, x and y. So what is a function? You know, we look at this relation and we know it's a pairing of elements, but what does a function actually really represent here? A function is a relation, but it's a very specific type of relation in which each element of the domain is paired with exactly one element of the range. So we're looking at something very specific here. All functions are relations, but not all relations are functions. We're going to look at, in terms of determining if a relation is a function, by looking at a couple different ways that a function can be written. But once again, this is where each element of the domain is paired with exactly one element of the range. So we can't have one x value going to two different y values. It can't be paired to two values of the range. First off, if we're looking at a graph, typically we do the vertical line test. That's just a quick check to see whether the x values repeat, because if they do, then that means one x is going to more than one y value. If we're looking at ordered pairs or tables, we really just look at our x values. We compare them once again to see if they're getting mapped to two different y values. Mapping, kind of the same thing. It just looks a little different. If you don't remember what a mapping is usually when you got these two sets and you're drawing arrows to different things. We're looking at, are the domain values, are these x values used more than once? So on the example I just kind of threw on here real quick is that, you know, let's say this is 3 and we got 4 and 2. That 3 is getting mapped to two different y values, so that would not be a function. So that's what you're looking for in terms of the domain values being used more than once. And then equation, maybe one of the harder ones to do is the equation. To me, what equation are we talking about? What does the graph look like? Is it linear? Is it quadratic? Exponential? You know, what are the things that we're looking at here? And if you can't, or you don't know what it looks like, because we don't know exactly what every equation looks like, especially when you start combining different types of equations, think about the possibility of having one x and two different y's, you know, and think about if you plug the value in for x, would you get two y's back, and if two different y's, and if you did, then it wouldn't be a function because it doesn't match up with that definition. So that's kind of what we're looking at in terms of identifying whether a relation is a function based on the different ways that we see it. Function notation. You guys are all familiar with function notation. F of x is equal to some value of the function at that specific x value. So we're going to look at just some different functions here, f and g, and we're going to evaluate those functions for a given x value. The first two are very specific as to what we're looking at, f of negative 2. So with f of negative 2, you would want to plug in wherever there's a negative 2, and this is f, so we're going to plug it into the f function. Wherever there's an x, you're going to plug in negative 2. And then you'll evaluate that at negative 2. Now in the first part here, x was being squared. So when I go to plug in negative 2, it has to have parentheses. So negative 2 is being squared. So it's 4 plus 6, and that's 10. So f of negative 2 is equal to 10. What does that mean? Well, the input is negative 2, the output is 10. That's an ordered pair on that function. On the second one, g of 2/3. So we would plug in 2/3 wherever there's an x value. Evaluate. Absolute value is a grouping symbol, so you do what's inside the grouping symbol first. And then 4/3 minus 4. Once again, you can do that in your head or find a common denominator, whatever you need to do. I'll show you common denominator part, so you can find a common denominator of 3. So 4 minus 12 is negative 8/3, and then the absolute value of negative 8/3, the distance from 0 is 8/3. So g of 2/3 is equal to 8/3. Once again, when the input is 2/3, the output is 8/3. On this last one here, not necessarily something I'm going to be asking you to do in this unit, but I did want to show it to you. This is something we're going to be doing at the very end of the semester, dealing with limits and derivatives. And I just wanted to show you that, you know, this is still the same thing that you learned in Algebra 1 and Algebra 2. It's just got more stuff going on. So I'm going to focus on the f of x plus h. What does that mean? Well, same thing it meant on A and B. Wherever there's an x, you're going to plug a negative 2. Wherever there's an x, you're going to plug a 2/3. Wherever there's an x, now we're going to plug in x plus h. So wherever there's an x, this x plus h is going to get plugged into. So there's an x here that's being squared, and there's an x that's being multiplied by 3. So I'm only going to focus on that first part of it. And so what is that equal to? Well, this would be equal to x plus h squared minus 3 times x plus h. So wherever there was an x, we replaced it with x plus h. And now we really just need to simplify that. The second part of it, which is the minus f of x, well, we already know what f of x is. So we have minus, but it is a quantity, so we need parentheses, minus x squared minus 3x, and then all of this is being divided by that h value. So that's what c represents, and then we can take this and simplify this down as much as we can. But this is really what we're going to be doing at the end of the semester. Now we still can be doing some of this stuff, maybe not as complex, but to get you prepared for the end of the semester. Let's simplify this so we can see what it looks like. X plus h squared, that's x squared plus 2xh plus h squared. That middle term is because x plus h, you have to expand that out. That's a binomial times a binomial. Then we have minus 3x minus 3h, and then distribute the negative, so that's negative x squared plus 3x all over h. And when you look at this stuff, you're going to start seeing some things cancel out, and then we'll simplify. So we got x squared and negative x squared. We also have negative 3x and plus 3x. So what's left, looks like we have 2xh plus h squared minus 3h, so we can't combine anything. And so at this point, some of you might feel like we're done. We've simplified as much as we can, but we can actually go one more step. If you noticed, there's an h in common in the numerator. And so once I factor out that h, I'm able to actually cancel those h's. And so my final simplified problem at this point would be 2x plus h minus 3. And what does that mean? Well, we'll have to wait till the end of the semester to kind of find out what all that represents. But you're definitely going to have to be able to simplify functions more complex than maybe what you did in your other classes. So this is just kind of a start of it. The next part I want to get into is the domain and range. So I'm going to kind of show you different levels of problems that you've done up to this point. So the first A and B represent really some Algebra 1 stuff. All right, stating the domain and range. So we would say D, or the domain, and then we just list them out. We got 1, 2, 4, and 3. We put them in numerical order with no repeats. And so there's your domain. Range. Same thing, except now you're going to do your y values. So your y values are 3, negative 2, negative 2, and 3. We have some repeating numbers there, so we're not going to write them twice. We're only going to write them once. And we're going to put them in numerical order. So in terms of the domain and range, that's kind of more of an Algebra 1 skill. Still need to be able to do it. Just list out the domain and range. Are these functions? Well, do I have an x value going to more than one y? And in this case, I do not on this one, so this is a function. And so you do the same thing for B, same idea, list them out. I'm not going to do it again, but just to look, is this one a function? You got 6, 1, negative 9, and 6. So you got 6 being mapped to negative 5, and also 6 being mapped to negative 1. That cannot happen. So on this one, this is not a function. And then once again, we could do domain as well, and range. But that's kind of more of an Algebra 1 thing. Then you get into Algebra 2 and you say, okay, now I know what the graph looks like. I can tell whether it's a function or not pretty quickly. But then we start getting into domain as well with these. And these are a little bit more challenging because they're not just a finite list of numbers. These are infinite. And by the way, those do go on there. That's an arrow. And so what's the domain? Well, your domain is your x value. So how far does this parabola open left and right? How far does it go? Well, it keeps going. So on this one, your domain, and I'm going to do this in interval notation, your domain would be all real numbers. So negative infinity to infinity. And if you haven't done or worked with interval notation as much as maybe you should have, let me know in class and we'll talk about it. The range is the y value. Okay, well the y value, the smallest y value is all the way down here at 0, 0. Alright, that's as far as that y value goes. But how far does it go up? Alright, it goes to infinity. So your range is all values of y greater than or equal to 0. And so now we have to give a list of the domain and range instead of just giving, or sorry, not a list, but all the different values instead of just a finite list. So for D, sorry about that. So for D, I keep hitting your domain, now since we have it kind of shifted, your domain at your x value, alright, your x value, the smallest it is right here at 2, 0. So your domain is all values that are greater than or equal to 2. And then your range on this one, now your range, how up, how far down does it go and how far up does it go? Well, once again, it's a parabola, so it's going to continue to open. So your range is all real numbers. And we use parentheses with infinity when we're doing it with domain and range because it's not a number. And so that's kind of more Algebra 2-ish. And then we get into kind of more pre-calculus in terms of what we're looking at. So now you have an equation. Now you have to have a better idea of what it is that you're actually looking at since you don't have the physical picture. And if you recognize on E, we have x squared. So we know it's a quadratic, and if we rewrite it as y equals negative x squared plus 1, then we know it's a quadratic. And some of the things, I mean, you can either graph this on your calculator, or if you have a pretty good idea of knowing your transformations and what the graph looks like, this graph opens down but is shifted up 1 unit. So it's going to look something like this. That gives you enough idea as to identify what that domain and range are. Like I said, you can plug it into your calculator to kind of get that same picture. And so your domain, since it is a quadratic opening up and down, is all reals. And then your range, what's that range? Well, what's the smallest value? Well, it goes down to negative infinity. It's just going to keep going. But it only goes up to this point, which is at 0, 1. So that's as high as it goes. So you always start with the smallest number, which is negative infinity, up to 1, and then you use brackets on that to include it. Okay, so there's another idea. Once again, you have to know what it looks like. You got to get an idea of what these different types of functions are that you've learned throughout all your algebra classes and geometry classes as well. And then on part F, I'm not sure if anybody recognizes this, but since some of you just had trig, this is something that hopefully you might recognize a little bit more. X squared plus y squared is equal to 9. You have 2 squared terms. And so this is a circle, all right, and it's circle centered at 0, 0 with a radius of 3. And so on this one on E, I forgot to say whether it was a function or not, but it is a function, okay. And on F, you can tell it's not a function. It doesn't pass the vertical line test, but you can still do your domain and range. Your domain, since the radius is 3, your domain is going to go from negative 3 to 3. because it is centered at the origin. And your range, once again, because it's centered at the origin with a radius of 3, is at -3 to 3. But this one is not a function. Okay? And so, that's what we're looking at. A lot of different possibilities in terms of, can you identify something as a function or not being a function? And can you identify the domain and range as well? So that's something I think, the domain and range is something we'll definitely have to work on. That usually typically is a point of struggle, and so we'll continue to work on that throughout this unit and beyond. And then the last thing I'm going to have you guys do is, just to clarify, domain of a function. When you go to do this, and I want to make sure that I'm specific about what I'm asking for here, the domain is all real numbers. So we're not getting into imaginary and complex in terms of getting the imaginary unit and things like that. We're only talking about real numbers here, for which the corresponding values in the range are also real numbers. So it's not just the values in the domain have to be real, but also the values in the range need to be real numbers as well. And so on this one, just going to ask a couple quick questions, and I really want to focus on just the domain. I have both of them on here, but I just want to focus on the domain on this one. Can we find the domain of each of these? And so what I would do is really just pause right now, go through these and see which ones you can actually find the domain for. And use your calculator, like I said, if you need to. On the first one, the domain, it's an absolute value graph. It is not shifted up or down, so it's just going to be somewhere, whoops. It's going to be a V shape on that x-axis, so it's, like I said, it's not getting shifted up or down. So your domain, it's going left and right forever, so that will be all real numbers. You can plug in any value you want in for x. There's no restrictions. And if you plug in any value you want in for x, there are restrictions on your output because the absolute value is only positive. It's not negative in terms of the distance from 0. So your range is going to be values that include 0 to infinity. Okay, and so we can look at that in terms of the graphing calculator in class as well. That's one of the things we can work on. B, your domain. I said we didn't have to find the range, but I did on the first one. Your domain, can you plug in anything into a square root? Well, no, because you can't take the square root of negative numbers. And so we want to focus on what value of x is going to give us that smallest value that we can take of the square root. Well, we know we can take the square root of 0. That's the smallest one we can do. So what value of x gives us values that are greater than or equal to 0? Well, values that are greater than or equal to 3. So our domain are specifically those values. Values that are greater than or equal to 3. 3 would give us the square root of 0, and then anything beyond in terms of the positive or larger than larger than 3 would also give us positive. Anything less than 3, such as 2 minus 3 would be -1. Square root of -1 is going to be an imaginary number, and we're only dealing with the real numbers. If you wanted to practice the range on this one, I will tell you, it would be values that are greater than 0. Okay, once again, it's not shifted up or down. On C, we're only going to do the domain. We'll get into rational functions later on, but in terms of the domain, what are the restrictions? What can you not plug into a rational expression? Well, the denominator cannot be 0. So then all we need to do is say, okay, well, if the denominator cannot be 0, what value of t makes the denominator 0? And when you solve and you subtract 5 and divide by 2, you get -5/2. So if you plug in -5/2, that's going to give you divided by 0. We can't have that. So our domain is going to be all real numbers except for -5/2. So we're going to use parentheses right here, because -5/2 is not part of the domain, and then we're going to do union and then pick it back up on the other side of -5/2 and go all the way to infinity. So that's an example where you're covering basically the entire number line except that value of -5/2, and that happens with all your rational functions where the denominator could equal 0. On D, logarithms. Do you remember logarithms? We're going to get back into logarithms later on anyway, so we'll skip this. I'll give you the answer in case you wanted to see whether you knew what the domain is, but it has to be a value that is greater than 0. So we'll talk about that later, but just in case you remembered that. On E, now you have a denominator that is a quadratic. Well, you need to figure out what values of 0 for x make that. What values of x make the denominator 0? Well, to do that, we got to solve the quadratic. So it looks like on this one we can factor x minus 4 and x plus 3. So what two values give you a denominator of 0? That would be at x equals 4 and at x equals negative 3. And so those are your restrictions. Now this one's going to look a little crazy because of the two restrictions. So you're going to have to go from negative infinity to negative 3, union negative 3 to 4, union 4 to infinity. So all real numbers basically excluding negative 3 and 4. And then your last one, the domain of the volume of a sphere. Well, your R value. What can you plug in for the radius of a sphere? Well, you can plug in anything except for 0 and negative. So your domain would be 0 to infinity. So kind of a more real-life application. So anyways, that's the end of Unit 1.2, which is on functions. A lot of different things that we had talked about. Please make sure you guys do your homework on this and check your answers. Thank you.